Hello, my name is Kevin Chant. I work with the Microsoft Data Platform, and I also happen to be a Microsoft Certified Azure Architect. Because I like to think of myself as a member of both the Azure family and the Data Platform family, I thought I would do today's video as a crossover between the two communities. At the end of this video, you will have a better understanding of which SQL Server related services are available in Azure. Now, this video is one of 3 for the finale of this year's Azure Advent Calendar, which is being hosted by Gregor Suttie and Richard Hooper. To find out more about myself, you can look at my bio on my website, which is www.kevinrchant.com, or you can find me on Twitter, where I am at KevChant. Alternatively, you can look me up on LinkedIn, where my user profile has a user-friendly URL of kevin.chant.
Topics I will be covering today include Azure SQL, which is a fairly new addition to the Azure portal, compute offerings, which will be a quick recap of the ones available for SQL Server, SQL Server virtual machines, what your options are for them in Azure, and when they are suitable, Platform as a Service offerings, where I discuss Azure SQL Database, purchasing models, and Azure Synapse Analytics. Other services, where I discuss other services linked to SQL Server, like Azure Kubernetes Service. And to finish things off, I discuss the applications to use of these services. In addition, I will show you how Azure SQL Database and Managed Instances both look in SQL Server Management Studio. I will also show you how you can deploy a big data cluster using a wizard in Azure Data Studio. Anyway, let's begin. Because you will see me using it in today's video, I thought I'd better discuss Azure SQL first. Now, in the past, the SQL Server related services were scattered around in the Azure portal. Because of this, you had to navigate around the old style dashboard or search for it at the top of the portal. By the way, for those of you who haven't seen this home screen before, this is Azure Home, which Microsoft introduced some time ago as an alternative to the traditional dashboards in Azure. Anyway, in August this year, Microsoft decided to create Azure SQL, which is one central place for you to manage your SQL Server resources in Azure. As you can see here, I've logged into the Azure portal using one of my test accounts. From here, I can easily select Azure SQL from my default Azure home screen. Afterwards, I can create different SQL Server services here with an easy to use wizard. I should point out here that a lot of you only use this portal when testing features. When it comes to looking after them in production, a lot of you will end up using PowerShell or applications to manage them instead. Just to quickly recap, there are 2 main types of compute offerings available in Azure that you can use to host your SQL Server databases. Now, when I say compute offering, I mean how the services are presented to you in Azure. One is Infrastructure as a Service, or IaaS, which is where you deploy an entire virtual machine with SQL Server installed. This is a good option if you know you want to quickly move your SQL Server instances to Azure as a first step of a migration, before you look to migrate them to use a Platform as a Service solution instead. Which brings me nicely to the second type of compute offering I want to discuss. Platform as a Service, or PaaS, allows you to have your SQL Server database or instance directly available in Azure without any underlying operating system in place. For example, after logging into Azure portal, you are presented with the SQL Server application itself, which means there's no operating system to log into. Which also means you're no longer responsible for the patching and maintenance of any operating systems. Of course, I will demonstrate this later in the video. These days there are other compute offering terms used. There are a couple of them I will cover during the course of this video. The first one is Database as a Service, or DBaaS, which some people use to describe platform as a service offerings based on databases in Azure. Another is containers as a service, or CaaS, which some people use to describe services that manage containers, like Azure Kubernetes Service. Now we've covered these compute offerings, let's break down the SQL Server related services in Azure a bit more. As I mentioned earlier, you can deploy virtual machines in Azure with SQL Server pre-installed on them. If you use this method, then the amount you pay in Azure for these virtual machines includes the SQL Server licensing cost. Now, because these virtual machines are based on an image, you may have to customize them after you have created them. For example, here I am connected to a SQL Server virtual machine using a remote desktop connection. By the way, as you can see here, this is actually based on SQL Server 2019, which was released last month. Now, if I click on the services, you can see that you may want to change the login details for the service accounts, or you may want to add additional SQL Server features. However, instead of using a Microsoft built image, you can also build a SQL Server yourself on premises, and then prepare the server to be used as a template for future installations by wiping all the unique information from it. In Windows, you do this using a tool called sysprep. Now after you've done this, you can upload this template as an image into your Azure subscription for use. Bear in mind, if you use this method, you have to check you are covered as far as licensing is concerned. One option you might be able to use to cover your licensing costs, if you have your own image, is to register your custom SQL servers with the SQL Virtual Machine Resource Provider. Doing this allows you to have more flexibility with licensing, and allows you to take advantage of things like automated patching and backups, similar to what you can see if I drill down into the virtual machine here. You can also simply deploy a virtual machine with just an operating system into Azure, and then install SQL Server afterwards. Again, bear in mind if you do this, you have to check you are covered as far as licensing is concerned, and you might want to use the resource provider I have just mentioned. One key point about infrastructure as a service is that you are responsible for the patching and maintenance of these virtual machines in Azure. If you are going to use infrastructure as a service for SQL Server, I recommend that you look at ways to automate things as much as possible. You can configure some of this in the portal on a per machine basis, as you can see here on the left hand side. However, to manage multiple servers, PowerShell and ARM templates are probably more suitable. If you use PowerShell, try and use the latest AZ module, which is made available in the PowerShell gallery, because it contains more features. Now, ARM templates are basically JSON files in a certain format that you can use to specify what you want to deploy into Azure. I can show you what they look like here by drilling down into the virtual machine itself, scrolling down on the left hand side and selecting Export Template. Now these ARM templates are known to be idempotent, which means if you delete a resource, you should be able to reissue the template to restore the deleted resource. Now, two things I want to mention about idempotency here. First of all, using programmatic logic in your ARM templates can stop them from being idempotent. Secondly, never mispronounce idempotent when recording a video. In addition, there are some extensions you can add to your virtual machines to help with other tasks like patching and backups. Note that some of these extensions cannot be added to your ARM templates though, as you can tell from the error message at the top of the screen here. Now that we have looked at virtual machines, I will discuss platform as a service offerings available in Azure. Let's start with the traditional Azure SQL database offering, which is a platform as a service solution which presents a single SQL Server database for use. Within Azure, you can easily create a single Azure SQL database. However, even though each Azure SQL database can be used by itself, each one must belong to a logical server that you create in Azure. Because it's a logical SQL server, you can only manage it through Azure, so you cannot connect to one using a remote desktop connection. As you can see here, there are still various things you can configure for these logical servers within Azure. In addition, I can drill down into the Azure SQL databases that are connected to this logical server. You can see there's still a lot of things you can configure for the Azure SQL database in the portal alone. For example, being able to write your own SQL queries in Query Editor, which is currently still in preview. And in addition, able to easily set up replication using geo-replication. You can also manage Azure SQL databases using PowerShell. And you can connect to them in SQL Server Management Studio, which I will show later on in this video. In the beginning, Microsoft introduced Azure SQL Database to present a single SQL Server database that you could access in Azure. However, extra functionality has been added over time to meet business needs. For example, you can group some of these databases together to share compute resources. When a database is busier than usual, it can use more of these resources and then release them when no longer required, so that other databases in the same group can use them, which is a concept Microsoft calls elastic pools. I will show you how this looks in Azure SQL. As you can see here, I click on the test pool that I have created and then click on Configure. From here, I can change my elastic pool settings. Or I can click on the Databases option and scroll down to see which databases belong to the elastic pool. As you can imagine, this is very useful when you have multiple databases that are busy during certain periods. Now you can choose between two types of purchasing models for the traditional Azure SQL database service, which are DTU based or fee call based. By default, the wizard shows the fee call based purchasing model. To view the DTU based purchasing model, select the Looking for Basic Standard Premium prompt on the left hand side. Now, DTU stands for Database Transaction Unit. It is the original purchasing model that was used when Azure SQL Database was first released. It is based on the fixed measurement Microsoft came up with to represent the amount of compute required by SQL Server. Fee call based model, on the other hand, is more flexible and allows you to specify separate compute and storage resources you want to use. Now, if you decide to use the fee call based model to deploy Azure SQL Database, you have a choice of 3 tiers, which, as you can see here, are General Purpose, Hyperscale and Business Critical. One of the main things to realise here about the General Purpose tier is that it's the best tier for testing new things, because it is the cheapest, especially if you are testing using a Visual Studio subscription and you have limited Azure credit. Now, it's worth noting here that if you use the fee call based model, you can also choose how you want the compute to be created, whether you want it to be provisioned in advance or alternatively dynamically created for you as and when you need it, which Microsoft calls serverless. Hyperscale is the newest offering available. It allows you to deploy a version of Azure SQL Database which is designed specifically for people that have high transactional requirements in SQL Server. In fact, it's the first SQL Server related offering that was architected specifically for the cloud. Business Critical tier, on the other hand, is the one recommended for your most important workloads because it offers low latency and high resiliency. In addition, In some regions, you can also choose which generation of hardware you want to use. Basically, whether you want to use an older or newer processor with these databases. As you can see in this particular example though, you can only currently select Gen 5. Up until now, we've mostly focused on the single SQL Server database offerings in Azure. Now it's time to discuss Azure SQL Database Managed Instances, or simply put, Managed Instances. Basically, for many years, Microsoft only presented the servers based on a single database. Finally, they released an offering presenting an entire instance instead. In addition to this, managed instances are thought to be more secure, because they are installed within a secure virtual network. Now, there are some caveats to using managed instances, so I suggest you do your homework online beforehand. And just to set realistic expectations here, managed instances can take a while to deploy. In fact, Microsoft states this now if you go to deploy through the portal. For example, the fastest time I've been able to deploy a managed instance is 3 hours and 42 minutes, and that's by turning all the compute settings right down. Here, I will show you how a managed instance looks in Azure Portal. You can see various options on the left hand side here, including Quick Start, which contains various items, including a couple of ways you can connect to your managed instance, since it is secured within a virtual network. For instance, you can create what's known as a jump box, which is a virtual machine that you can think of as a go-between from the machine you're currently working on and your managed instance within a secure virtual network. Alternatively, it gives you the option to create a secure VPN connection directly from your machine into your managed instance. Later in this video, I will show you how a managed instance looks in SQL Server Management Studio. Azure Synapse Analytics is the final platform as a service offering I want to cover in this particular section. It was previously known as Azure SQL Data Warehouse. However, earlier this year it was rebranded and given additional functionality. You can still install an Azure SQL Data Warehouse as part of it though. Now, you're not able to create an Azure SQL Data Warehouse within Azure SQL. However, as you can see here on the screen, you can still see the logical SQL Server for an Azure SQL Data Warehouse if you create an Azure SQL Data Warehouse elsewhere. And you can drill down into it, select SQL Databases, and then select the Azure SQL Data Warehouse that you have created. Now, Azure Synapse Analytics allows you to query data from Data Warehouse and Big Data solutions that are petabytes in size using SQL. In fact, you can use a lot of the Transact SQL language that comes with SQL Server within Azure Synapse Analytics, which makes it easier to use if you have a SQL Server background. Whereas Azure SQL Database uses DTUs to represent the amount of compute units, Azure Synapse Analytics uses DWUs to represent scalable units, which stands for Data Warehouse Units. Some of the new features since the rebranding are still in preview. For example, being able to view streaming jobs and using Power BI. From the amount of excitement Azure Synapse Analytics has caused since its announcement at Ignite, it's worth looking into. I thought I'd give some honourable mentions to some other Azure services that are linked to SQL Server. First, I want to mention Azure Data Factory, which is gaining popularity and is recommended for use with Azure Synapse Analytics, which we have just discussed. You can think of it as a version of SQL Server integration services hosted in Azure, even though it is fairly different. Second, I will quickly mention Power BI here, since we just talked about it in the previous section as well. It's a powerful data visualization tool, which is also very popular in the data platform community. it allows you to produce powerful reports and dashboards. Thirdly, I thought I should mention Azure Kubernetes Service, or AKS, because it can be used with a new feature that comes with SQL Server 2019. That is called Big Data Clusters, which you will see shortly in this video. Basically, you have to host big data clusters on a Kubernetes service somewhere. And Azure Kubernetes Service is one of those services you can deploy big data clusters onto. I want to cover some applications you can use to manage these SQL Server services and related offerings. First of all, there's SQL Server Management Studio, which is a traditional tool people have used over the years to manage SQL Server. Now, here I'm using a Jumpbox server, which I created earlier after creating the managed instance I showed you previously in this video. As you can see, I'm actually connected to two completely different services here, as you can tell from the different icons. The top one is Azure SQL Database, which you can connect to from one of these jump boxes, as long as you have your Azure SQL Database configured to allow connections from your Azure resources. If I expand it, you can see how an Azure SQL database is actually presented in Management Studio. Now, below that is actually a managed instance. If I expand a managed instance, you can see how it appears to be similar to a SQL Server instance that you can install on premises. Next, I want to show you Azure Data Studio, which is a newer application that has been introduced by Microsoft. And for those of you who know branching terms, it is forked from Visual Studio Code, which is why it might look familiar to some of you who have yet to see it. Its main advantage over SQL Server Management Studio is that it is multi-platform, which means it can also run on both Linux and Mac OS. Another advantage is that you can run notebooks within Azure Data Studio, which you will see shortly, because, as I'm about to demonstrate, you can use Azure Data Studio to deploy big data clusters. So, as you can see from the connection screen, I can click on the ellipsis and select Deploy SQL Server. From there, I select SQL Server Big Data Cluster, accept the licensing terms and click Select. Now, once the configuration templates have loaded up, I will select AKS-dev for the sake of this demo. However, on the next screen, I will make one slight change so that I don't get caught out by any issues by core limits within Visual Studio subscription. So just be aware that by default, if you're going to do this using your Visual Studio subscription, you only usually have a maximum of 20 cores allowed per virtual machine size. You can work around this in various ways, including contacting Microsoft for a quota increase. Another thing to bear in mind relating to that is that if you change either the location or the virtual machine size, make sure the virtual machine size you select is actually available in that specific location. Now, I do have a blog post with some guidelines relating to this, and I do suggest you go and read that if this is what you want to do. Anyway, carrying on with the demo, I select Next. From here, I enter in a password. Now I click on Next. I accept the defaults again. And then I click on Script to Notebook. And as you can see, what this actually does is generates a notebook within Azure Data Studio, which then I can run all the cells to deploy big data clusters. However, this does take some time to do. So what I am going to do is actually pause this demo and then come back to you once I've deployed a big data cluster. Now that the wizard is finished, you can see that the results in the notebook shows you all your main big data cluster endpoints. If I scroll down, I can connect to the SQL Server master instance for the big data cluster. Once open, I can navigate through objects on the left hand side. Or alternatively, click on the SQL Server Big Data Cluster tab to perform essential Big Data Cluster tasks. Or I can click on the Data Virtualization tab and use Polybase to create an external table. This goes to show just how useful Azure Data Studio can be to manage big data clusters. A few other applications I want to briefly mention include Azure CLI, which is the Azure command line tool, which is easy to use and can be installed on either Windows, Linux or Mac OS. PowerShell can also be very useful for deploying and managing services in Azure. Quick tip though, if you're still using the old Azure RM module, you may want to migrate to the newer AZ module instead. Finally, I want to mention a command line tool called kubectl. If you are going to look into big data clusters using Azure Kubernetes Service, then I recommend you learn how to use this, because it can be a very useful utility. Anyway, that's it for me. I hope you enjoyed my personal review of SQL Server related services in Azure. In addition, I hope you enjoyed today's finale to the Azure Advent Calendar. You can find out more about what we discussed today on my blog post, which has also been published today. In addition, I will also be providing some links in the credits shortly. Happy holidays, and for those of you who celebrate it, Merry Christmas and a Happy New Year.